Okay, so the last of the rules that we need to look at is called our quotient rule. And as the name suggests, the quotient rule is when we have two functions dividing each other. Okay, so the function's u on v. All right, now similar, if I have the function u over v, then the derivative of that is, in this case, it's the derivative of the top times the bottom minus the derivative of the bottom times the top over the bottom squared. Okay, so order is important in this one, whereas on the previous case it didn't matter which function was first, it's just the derivative of one times the other and we add them. This time around with a, we've got to subtract them on the top and then it's the bottom function all squared. So again, same principle, let's put u equal to x, which means u dashed is equal to 1, and let's put v equal to 2x minus 1 squared, which means v dashed is equal to 2 at the front, 2x minus 1, take 1 from the power, times the 2 inside, which is 4 times 2x minus 1. All right, so now then, my derivative will come up here a bit, f dashed of x is equal to the derivative of the top, which in this case is 1 times the bottom, which is 2x minus 1 squared, subtract the derivative of the bottom, which is 4 times 2x minus 1, times the top squared, which is x, all over the bottom squared, which is 2x minus 1 squared, all squared. Okay, so the derivative of the top function times the bottom, minus the derivative of the bottom function times the top over the bottom squared. So we get to simplify that with, I've just got 2x minus 1 squared minus 4x times 2x minus 1 all over 2x minus 1 to the 4. So looking at the top, hopefully you can see 2x minus 1 is a common factor. 2x minus 1 comes out the front, and I've got a 2x minus 1 minus 4x over 2x minus 1 to the 4. They cancel down. That becomes to the power of 3. That cancels out. So if we simplify that expression there, that will give me 2x minus 4x is minus 2x. So it gives me minus 2x minus 1 over 2x minus 1 cubed. Okay, so possibly you might take the negative sign out the front and write 2x plus 1. But in reality, it's the same thing. All right, but again, my argument will be if that even, I guess, that line and that line makes sense, you understand the quotient rule, it's then just working on the algebra side of it. All right, so let's do our last one. Need a bit more space here. All right, so same principle. Let's put our u equal to x, the top function, put v equal to the bottom function, which I'm going to write as 2x squared minus 1 to the half. All right, therefore u dashed is equal to 1. V dashed is equal to, multiply by the power, 2x squared minus 1. Subtract 1 from the power, which is minus a half, times the derivative of the inside, which is 4x. Simplify that a bit. A half times 4x is 2x. And quite possibly it might be easy to write that as 2x squared minus 1 to the power of a half on the bottom. All right, so there's my 4 rules, or my 4 functions. So f dash of x, we might need a little bit of that, is equal to the derivative of the top, which is 1, times the bottom, which is 2x squared minus 1 to the half, subtract the derivative of the bottom, which is 2x over 2x squared minus 1 to the half, times the top, which is x, or over the bottom squared, which is 2x squared minus 1 to the half, all squared. All right, so there's my quotient rule. Now, what have we got? Let's concentrate. Well, the bottom looks okay. It's something to the power of a half squared, so they're going to cancel out, aren't they? So let's just get a nice big vinculum there. The denominator is going to become 2x squared minus 1 to the power of 1, if you like. So let's go in here. Let's simplify a fraction first. So we've got 2x squared minus 1 to the half, subtract, x goes into that, 2x squared over 2x squared minus 1 to the half. Now, that numerator, let's just treat the numerator up here separately. There's that 2x squared minus 1 to the half as a common factor. So remember the previous example when we took a 1 on root x out the front? Well, I'm going to do exactly the same thing here. I'm going to take, might rub that line out. Let's rub that line out. So I'm going to take 1 over 2x squared minus 1 to the half out the front. Now this is just the numerator, okay? So if I take that out the front, I've got, in fact, let's do it in a different color again, just to be consistent with the last time. Let's take it out the front with, I don't know, blue. I'm going to take that out the front, 2x squared minus 1 to the half. Now that term there I'm taking out the front is this one here, all right? So that leaves me with the first term, which is still 2x squared minus 1 to the power of a half. But if I want these two terms to be the same, I'm going to introduce another 2x squared minus 1 to the half, because now in reality, I won't cross them out. That would cancel out. Those two blue terms would cancel out. So I still have equality. And then I've got minus, well, I've just got 2x squared there now, because I've taken the 2x squared minus 1 to the half out the front. So that's my numerator, all over 2x squared minus 1 to the power of 1. So my next term, this term in blue out the front here, what if I put that down and write that as 2x squared minus 1 to the half. I've already got this other 2x squared minus 1 to the 1 there in the bottom. And now I've got this black bracket here, 2x squared minus 1 to the half times 2x squared minus 1 to the half will give me just 2x squared minus 1 to the 1 minus 2x squared, which gives me, well, 2x squared minus 2x squared is 0. So that gives me a negative 1 on top over, these two things have the same base, so I can add the powers. So that gives me 2x squared minus 1 to the 3 on 2. Okay, so again, where are we going to highlight? Let's highlight here. It's really to this point here. If that's okay there, we've got a handle on our quotient rule, all right? That's why we're going to have to practice. You've got to practice these, boys, because the algebra side of it you get used to, and you end up doing the same thing a lot, especially these sort of square root ones here. all right? We get common factors in both A and B. There's common factors there that you take out the front and you group your terms together. So that's why we've got to practice the skills, all right? So I guess there's three things we're looking to identify. If we've got what we would consider to be composite functions, so I guess in some ways a summary, if we have a composite function, okay, we're looking at a chain rule. If we have a product, in other words, two separate functions, okay, we have the product rule. If we have a division, we've got a quotient rule, okay? So you've got to practice all three, okay? And at the moment, the examples we looked at are really just our polynomial functions, but you know, we'll have functions like e to the x over cos x. Okay, if for no other reasons, just to see if you can work out the derivative of them, e to the x times cos x. All right. Can you identify you have a division of functions there and you need to use a quotient rule? We've got a product of functions, so we need to use the product rule. All right. So take a bit of time. There's a lot in this one. All right. And just practice, practice, and practice.